Chair of the Public Utility Commission. With me is Sarah Hoffman, Margaret Cheney, our acting general counsel, John Cotter, and our head of policy, Tom Nauer. And this is case number 17-4986 INV, a workshop on best practices related to fallen objects at wind facilities. And our purpose is education. That is, you educate us. And the scope has been laid out in an order that was issued on the 10th of January. And the goal here is to focus on one topic, namely hazards associated or not, as the case may be, with the operation of wind turbines caused by objects falling from those turbines. And we, of course, have cases in front of us related to wind turbines, and we will not allow discussion of any of that here today. And I'm sure you all, most of you, like I've seen you before, and you know how the game is played. So we appreciate your willingness to stay with that. We know that there'll be presentations, and if you need, we can turn the lights off to allow that to appear better. I want you to know that there is an improved hearing room in our future. The wheels of justice grind slow but exceedingly fine. And hopefully, in time, we will be able to do this in a way that you can sit in your home and not only hear, but a limited number of people actively participate in our proceedings. But for now, it's here with the wall. The schedule for today is that we need to adjourn by 4 o'clock, but we don't need to stay until 4 o'clock. So it's up to you guys, and I will leave it up to you to decide who's going to speak and in order. If you've talked to each other, that's great. If you need a referee, let us know. Okay. Thank you. Sarah's reminded me. So I guess we should have everybody in the room, if you would, introduce yourself. We'll start over here.
Hi, I'm Carol Flint. I'm the Director of Consumer Affairs and Public Information with the Vermont Department of Public Service.
Okay.
Good afternoon, John Brabant. I work for Vermonters for a Clean Environment.
Okay.
Cindy Hill.
Elizabeth Schilling, staff with the Commission.
John A. Smith, Swanton, Vermont.
Patty Rainville, Swanton, Vermont.
Greg Pierce, private citizen.
Paula Kane, private citizen, St. Albans, Vermont.
Preston Gregory, Green Mountain Power.
Justin Lindholm, Vermonters for Clean Environment.
Penny Doobie, Fairfield, Vermont.
Bryan Doobie, Fairfield, Vermont.
Annette Smith from Waters for a Clean Environment.
Sally Golaby, Fairfield, Vermont.
Sanj Lewis from Dunhill Saunders.
Hal Cohen, a specialist in the Department of Public Service.
Jeff Carmen's Public Service Department.
Great. Thank you. All right. So, who started?
I think I'm going to start, Mr. Chairman. So my name is Bryan Doobie. I'm a citizen with my wife Penny in Fairfield, Vermont. The purpose of this hearing is to educate and to share. And for myself, that's been a journey. And education, I almost feel a little bit responsible. I'm grateful for the PUC for asking for the workshop, for kind of an informal opportunity to share some information. And that's I think it's a really smart thing to do. It kind of out of the formal process. So these are some of the things I have learned and felt an obligation to share with the PUC. In addition, being a sugar maker, I am an airline pilot. I've been on aircraft that have propellers that shed ice. I know about propellers, building ice and shedding ice. I have a degree in mechanical engineering. And many of these concepts are simple engineering and physics concepts that manifest them in huge objects called wind turbines. A wind turbine today, the modern wind turbines are basically taking a 747 and sticking it on a pedestal. That's the size of the turbines, the modern turbines. And from a survey of what's going on in the world, the turbines are getting bigger. So that leads us to, this is one person's opinion on, Penny and I put this together, but it is my opinion from learning from other projects that we're not going to talk about, it's my opinion that we could do a better job of being more thoughtful going forward as a state in terms of proactive regulations that give clearer signals to developers so that they could have some better clarity about what they're going to find from the reaction from neighbors to projects they propose. So this is not just for neighbors. This is, in my opinion, it would help developers. I'll start right off with a presentation. It's my recommendation that turbines should have a setback from property lines of 4 times turbine height. You're right, there's a little scoping, so I apologize. I've got a couple slides that are a little bit outside of objects, but I'll be brief, and they're in the presentation. First of all, that recommendation is consistent with manufacturers' recommended setbacks, and we're going to go through some slides. This is an overview of the slides that I have. I was also told that, Brian, the best way that you could help us at the PUC is look to see what other municipalities set for setbacks. So I have 3 slides on, not a formal survey, but, from digging around some other examples. Setbacks protect against ice throw, blade throw, and turbine fire. Setbacks are consistent with acceptable levels of risk because we live in a world of risk. Nothing is certain, crossing a road, putting up power lines, wind turbines. So it's all about managing acceptable levels of risk. I have a slide on that. And we're not going to go into the Constitution, but I do think it's a fact that Vermonters have property rights as expressed by our Constitution. That's the first slide.
So, I'm sorry,
Yes.
that's probably what the staff already asked you. Do we have a copy of these slides?
I'm sorry, I'm glad you asked. I made 3 copies.
Thank you.
You're welcome.
Thank you.
You're welcome. And I can
I
get
was
some
putting
more.
my notes up. So.
Yes. Excellent.
I actually assumed they're electronic, so
Yeah,
if you think
we
of
did-
it,
we
you
did
just
s-
file it in the docket in EPUC, and then others
Everybody can see
will
it.
be
Okay.
able to see it.
Outstanding, thank you. You asked that this be out of the scope. I did find it provocative that Minnesota talks about setbacks to protect property owners that in a future date might want to put up their own turbine. And the 5 times, their setback, and this is an existing regulation from Minnesota PUC, says 5 rotor diameters, and that's to protect other neighbors. We won't go into that today, but it is thought-provoking. It is looking into the future, and it's part of protecting neighbors' interests and a way that's consistent with, I think, the thinking of Vermont, being a good neighbor.
May I interrupt you?
Yes, ma'am.
So, do you know how the 5 rotor diameters compares to the 3 times the turbine height that you mentioned?
So I just picked an example. Yeah, and it's just so that's a turbine that is probably being discussed today, but about 2,000 feet.
Sorry.
Yeah. Yeah. Okay. And if you've been in the Midwest, you've been in the West, you see if a neighbor's putting up a project, you're probably going to think about putting up a project. So you wouldn't put a project right on the border because it wouldn't be neighborly to your neighbor. And that's a setback that says, this is a way to set some clarity amongst neighbors so that there's not an interference. When a project is put together, there is a real concern, and they have to be really careful about making sure that turbines don't interact with each other. That's not just for optimizing the wind, it's also for the insurance companies drive that because it sets up turbulence that will cause turbine stress and wear. So turbine separation is a part of very important part of a planning for a project. Next slide, please. Yeah, just a little picture that the next area I'd like to talk about is manufacturers and operators have setback recommendations for their workers and for installation. Next slide, please. So I tried to pick just 3 examples of other setbacks that that are currently in that manufacturers advise. Now, worst case is a fire, but any rotating piece of machinery, could lose fluid, and if it loses fluid and it's not monitored, it could catch fire. And turbines do catch fire. I didn't prepare the numbers, but anything that rotates, be it a wheel assembly on an automobile or a jet engine, if you lose fluid, you're going to have potential for fire. It happens all the time, and it happens with turbines. So this NOREX is recommending 1,600 feet, and that's because if the turbine loses fluid and goes to a fire, what's going to happen is you're going to lose a blade, and the blade could be thrown, according to this manufacturer, 500 meters, which is approximately 640 feet from the turbine. Just as an example. Vesta, it's recommending, if you're inspecting or working on the turbine, you should stay 1,312 feet away. And that doesn't talk about fire, that's just in their manual, in the Vesta manual. And they also say, in the case of fire, in an uncontrolled operation, once again, evacuate and rope off a radius of 1,300 feet. And this is kind of building a case for what is the physics involved with a turbine blade that's spinning about 196 miles an hour at the end of the turbine. It's counterintuitive how fast that turbine, when you look at it on a distance, it doesn't look to be traveling that fast. But in fact, the forces of centrifugal force at 196 mile an hour turbine speed is quite fast, and it would, according to this Vesta, could throw a blade up to 1,312 feet. Next slide, please. So this is an interesting slide because GE is a company that is a great Vermont company in Rutland, Vermont. They make turbines for jet aircraft. Well, they also are very big into a very reputable manufacturer, and they do a lot with wind turbines. They have a manual, and in my printed, what I printed out in preparation for this meeting that was sent to the PUC, has all the web links to the manuals and all the highlighted links. So this is an abbreviated presentation of what I've already sent to the PUC. But they're recommending a formula that seems to be adopted around the world, and that's 1.5 times turbine height plus the rotor diameter. And for a modern 500-foot turbine, that translates into 1,038 feet. And that's a GE recommendation. And that's going to talk a little bit more about that as it relates to a project that they chose not to participate in Massachusetts on the Cape because they couldn't, the installation didn't give them this kind of separation. But that's an important number from GE. And that is not about blade failure, that is about ice throw. So we've got objects coming off the turbine that's rotating, and then we have, in the event of a fire or a blade failure, the blade coming off. So there are a couple different things that play here.
So I understand that distinction, but then, Lieutenant Governor, in terms of how does that compare to your 4 times? Is that because this is ice shedding and ice throw versus what you had on the first
so
project?
I came off with like a conservative starting point, which is 4 times. This is more something like 2.2 times, and that's limited just to ice throw. So when you throw blade failure into it, There's a worst case scenario where, so when we talk about 1,500 foot blade throw for a 500 foot turbine under nominal speeds, if you were to have a fire and there's scenarios where you're exceeding the design, some of these things at high wind, Puerto Rico, you've probably seen some of the, when there's tornadoes, the blades can go even further than that. But that's a very, this recommendation, for ice throw, it's something like 2.2 times.
Thank you.
You're welcome. And in the whole context for this, just to follow up on that question, the whole context is, right now, the guidance, the existing precedents, and I know the PUC is going on a case-by-case basis going forward, and that there's some logic to it. But from what I've seen, the precedent that exists now is the drip edge test. And that is, if you have a turbine on a hub and you have a blade, if ice was to fall, it's something like on the drip edge. So there's no rotational, no shedding, no centrifugal force. It's about 30 feet from the drip edge. That's kind of the precedent of what I've seen in the industry in the state of Vermont. So when I say 2.2, that would be greater than 2 times what we currently have. So here's a summary. It's not scientific. It's me looking at sources and trying to sort out. I tried to remove all the noise, setbacks for noise, to stay out of that issue. Next slide, please. I don't want to dwell on this. There's links to why these communities chose up, but the chair did recommend to me that it would be helpful to look at what other municipalities are doing. So this is just a survey of some of our neighbors in the United States and outside of the United States, starting with greater than 1 mile in Maine. And these are all chosen because they're to property lines. And that's what we're talking about today, is property line setbacks. So I don't think I need to go into much detail there, but you can see 6 times turbine height at the bottom, 3,000 feet for, and this is assuming a 500 foot, which is kind of the standard based on FAA maximum, 499 feet. But so based on a 499 foot turbine. Next slide, please. So you can see the state of New York, some communities have stepped forward and put some property line setbacks. And as I said, many of these have property line setbacks and noise setbacks, which are usually much greater than the property line setback. But for the purposes of today, just focusing on property line setbacks set by other communities. Next slide, please. Yeah, states like Ohio and Wisconsin have pretty sweeping property line setbacks. I know Ohio was there was some talk about revisiting that, so I'm not quite sure what that is right now. Riga Township, Michigan, gave me a very extensive presentation, and that setback is all about blade failure, and which drives, it's like a zoning, which is really to protect an adjoining property's owner if they ever wanted to build on their property. And they had a lot of work that developed at 1,640 foot, which is all about blade failure, blades coming apart. Worst case scenario, low risk, doesn't happen a lot, but it can happen. And a person that was reasonable and responsible probably wouldn't put a home or live or work in that, inside of that 1,640 foot feet, as determined by Ripley Township, Michigan. Yeah, and then you can see the GE guidance for communities. There's a lot of documentation about Europeans, Northern European countries setting forth proactive property line setbacks based on ice throw, which brings up that GE formula that we talked about before. Next slide. And then that's going to have I've got reams and reams of, and I think I sent those with the original request for the workshop. So there's a lot of graphics, a lot of more detail, but suffice it to say, this is just an overview. So, one of the things that we talk about, and your job is clearly is to manage risk. And I understand it, and we all manage risk, and life is not risk-free or hazard-free. It's all about what is acceptable. The reason I bring this up in this slide, you might say, Brian, what does water quality standards have to do with wind turbines? Well, the state of Vermont, in the water quality side, has put forth that it will prevent exposure to toxic substances that will exceed concentrations of a maximum individual lifetime risk to human health greater than 10 to the minus 6. That's one chance in a million. This is important, somewhat important, because you make these judgments all the time about infrastructure and projects that you choose to either redirect or improve. And I bring this up to be a little provocative about 10 to the minus 6 is a precedent that, at least on the health side, the state of Vermont has already established. Next slide, please. And why is that important? Well, because this slide is really about the an insurance company, Lloyd's Register Consulting. Lloyd's working with projects in Norway that all are about risk. This starts at minus, pardon me for the size, but that's 10 to the 0, 10 to the, it goes all the way to 10 to the minus 7. This is 10 to the minus 6, and what that basically says, if you're underneath the turbine, there's a pretty good chance you're going to get whacked with ice. And as you go further away from the turbine, the probability, and this is all about risk and probability, and the developers talk a lot about probability in their Monte Carlo analysis, but this out here is like 10 to the 4th, and this out here is like 10 to the 7th. Now, how does that translate? Well, over here, this is about, this data is pretty consistent with the GE formula that we talked about. That's 300 meters, that's about 950 feet, and it says as you go further away from the turbine, this is going away from the turbine in terms of meters away from the base of the turbine, this is out to about 1,000 feet, and this is probability that you're going to get whacked with a piece of ice. This assumption is not for a car or a bus. This assumption is assuming it's a person, a 2 square meter target. And that's why it's relevant. So, you know, that.
I may not be reading this right, but how long do you have to be standing there to be in this problem?
Well, these are all really important questions. And there was another slide, in the interest of time I didn't put it in, but that other, there's the follow-on slide in the same presentation answers that question. And what it means is, if you're in a hiking trail, there's I don't know the exact time, hiking trail, ski trail, has a certain assumption about how much time you'd be in icing conditions near this turbine, and then it goes all the way out to like a schoolyard. And the acceptable amount, they're basing this risk with the assumption of how much time you'll be under the turbine. From a regulator standpoint, it really doesn't, to really simplify this, this is where those kind of questions change, and it's really from, if you really look at the data, from 250 to 300 meters, it doesn't change an awful lot in terms of how much time you're going to be under, be exposed. Most projects in Vermont, and we have an expert here from Green Mountain Power, probably could tell us exactly at Lowell, but most projects in Vermont are exposed to something greater than 22 days to maybe something like 35 days a year. So there are icing, we can look at the met data, the metallurgical data, and we can predict how many days there would be icing. Suffice it to say, I wouldn't want to be within 1,000 feet, of a turbine in Vermont in the wintertime on a consistent basis, unless I had I had a camera or some means to know that there's not ice on that blade. But this is what one country and an insurance company have my recommendation is significant, is 2 times more conservative than this. But that's, in addition to ice throw, it also adds the turbine, the blade failure, which is going to go further than ice throw. Next slide, please. Any other questions? Yeah,
Question on that last slide.
Yeah.
What does the E greater than 40 mean? Do you know what that?
I don't know what that means. I'm sure it's in the, I can give you the presentation. I'm sure in 5 minutes we can figure that out. It might be the size of the target. The size of the, like if it's a bus, it's.
But this material is in the material originally filed.
Yes, it is, yeah. Yeah, good question. I'm sorry I can't answer that. In this slide, I put this slide in here to show that, so most projects in Vermont aren't on a flat plain, like in Norway perhaps, or in the Midwest. Most projects in Vermont are actually on a ridgeline. So this shows a project on a ridgeline, and basic physics, once again, if you have a spinning turbine on a ridgeline, you're going to get distance from the height of the, because the turbine is on a hill, you're going to be able to throw the ice ball further. And that's what this is showing. The distance is, once again, about 400 meters. That's kind of small, but it's 300 to 400 meters, something in there from the edge of the ballistics of how far a chunk of ice could go. And these are kind of developers' numbers. So these are people in the business that are trying to mitigate risk, and that's what their data is. Next slide, please. This is kind of beyond the scope, but I made the slide. Turbines do catch fire. They do collapse. They do throw ice. They come apart, and they'll throw a piece of a blade, or they could throw the entire blade. And, it's obvious that under Vermont's Constitution, private property is protected. Next slide, please. And part of the reason for this workshop is just my opinion. The fact is, adjacent property owners should be protected from wind developers who seek to possibly throw ice blades on private property and use their property as an impact zone. I think the PUC should be applauded for even asking, for what's the data out there. The status quo, I don't think is fair to developers, and I don't think it's fair to property owners. I think the PUC is really wise to, look at the data, and I really want to thank you for allowing us this time to share our thoughts, and I'd be happy to answer any further questions, or that concludes my presentation.
I think I got mine in there, and thank you.
Good.
Thank you.
Thank you
You're
very
welcome.
much.
You're welcome.
Helpful.
I'll get you the E.
Okay, just, can you just file it in EPUC like you would file anything else?
Okay.
It'll get out to everybody who participated in the workshop and get into our files.
Thank you very much.
Annette Smith from Augusta Clean Environment. I apologize that I meant to print out copies for you this morning and I forgot. So I will send it into EPUC.
Okay, great, thank you.
So the topic today is objects falling from wind turbines. This photo of showing danger falling ice hazard I took at the Iberdrola Lemster wind project in 2009. I went on a tour, and I am not aware that any signs like that exist in Vermont. I'm not necessarily recommending they should. I'm just noting that this is a practice that apparently Iberdrola does. I've also been at their projects in Pennsylvania where I've seen similar warning danger signs. But I'm not aware of any signs at any wind project in Vermont that has them.
I'm sorry, could you go back one minute? Is that a turbine base to the right?
Yes,
or-
that's a 2 megawatt Gamesa turbine. Yeah. Just to make it fit, I cut the top off. So this is sort of a why are we here slide, which is always challenging. Here we go. This happened in Portugal in January of this year.
Baby go.
And it's a Vestas turbine of a smaller type than we have in Vermont, but we do have Vestas turbines in Vermont. And it shows what happens with a turbine fire on a hill. I've watched many, 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 many videos of this sort of thing, and this is probably the best representation of what happens with blade throw during a fire. So this is a summary of what I'll be presenting. What are the issues? Have they happened in Vermont? Have they happened with the makes of wind turbines installed in Vermont? How often do problems happen, and at what distance, and what do scientific papers say? What are the issues? Well, for the purposes of today, blade throw, fire, tower collapse, and ice throw. Have they happened in Vermont? The tower collapsed at the Searsburg wind project. They're 197-foot tall turbines, 600 kilowatt. This is a photo from September of 2008. A blade was thrown. You can see it on parts of it on the ground, but also up in a tree. This was discovered nearly 3 years later up in the tree, so it hadn't been remedied within that period of time. Fire. Okay.
Excuse me,
Yes.
can you give us some idea of the distance at which that blade was found?
Do you remember?
Yeah, that was
I'm sorry,
Why?
can you say?
Justin Lindholm. I work for BCE. It was quite a ways away from the tower, and that tower, I think they had taken it down already, but I would say it was several hundred feet, probably 200 feet maybe. And the blade is actually, it's wrapped around that tree. You can see the bottom of both of them. You go all the way up and then come back down there. So it wrapped around with some pretty good force, and that's me standing beside it. And that tree is probably 2 feet in diameter. They took the whole tree down after I notified VOSHA of that violation of leaving it up there for 2 years.
There was a fire in one of the Searsburg turbines. See, you have to look closely, but there's the light here. This was taken by a neighbor. This was in November of 2015. Ice throw. This is testimony from Will Statz, who lives in Vermont, but he works for the New Hampshire Fish and Game Service. And he testified to the Vermont House Natural Resources and Energy Committee about his experience with ice throw doing field research projects at the Coos County, New Hampshire Wind Project, which has Vestas V90 3-megawatt turbines. And I think Green Mountain Power is buying the power from that project. He said, I would like to help dispel a myth regarding wind power, and that is the notion that Vermonters can recreate near these huge machines. It has been inferred that snowmobiling and hunting can coexist with an industrial wind turbine project, but I can assure you this is the last place one would or should choose to pursue these pastimes. The danger of ice throw cannot be overemphasized. I have often worked near these machines on our research projects in the winter and witnessed the large divots in the snow where ice has been flung from the turning blades. I have seen the steel stairs leading to the doors of turbines bowed and broken by ice falling from the nacelle. And on one terrifying occasion, my truck was struck by flying ice that, had it hit me or anyone else close by, could have killed or caused serious injury. One operator of a wind installation told me that these machines will throw a 400-pound chunk of ice 1,000 feet. How do these issues happened with the makes of wind turbines installed in Vermont? In Sheffield, we have Clipper wind turbines, 2.5 megawatt. This is the same brand. And this is from June of 2017, where it caught on fire and dropped a blade. At Georgia Mountain, we have Goldwind turbines. This is from Fenner, New York, where they have GE 1.5 megawatt turbines, but one collapsed and it was replaced with a Goldwind 1.5 megawatt turbine, and it dropped the blade in February of 2016. I should note that I believe that the setback at the Sheffield project is less than 200 feet from the neighboring property line. At Georgia Mountain, it is 188 feet from the neighboring property line, and those are 2.5 megawatt turbines, not this 1.5 megawatt.
And it's important when Annette quotes that setback, that is not from the tip extended, that is from the base. So if you have a blade that's 180 feet, the setback is something like 40 feet. So it's important to know, she's talking about setback from the base, not from the tip, especially with ice. So I think Georgia Mountain is 40 feet from the property line when you go from the tip to the property line. Something to that effect. I don't know the exact number.
This is a Vestas V112 3 megawatt, which is the same model, make and model that's on the Lowell wind site. That has a setback of 196 feet. Now the V112, whenever you see V90 or V112, that's the meter length of the blade. So this is 112 meters long, and here's another picture of it, the same one that collapsed in Denmark. Well, actually Sweden, excuse me. So that was in December.
Do they know what caused this kind of collapse? Was it wind? Was it
There are a lot of reasons for why these things happen. Some of it's bolt tightening wasn't done right. Some of it seems like a lot of it has to do with improper installation. But there are all kinds of reasons. There's some that have failed because of concrete failure. I have to say, this is a very large topic, and there's a lot of information out there, but it's very hard to find kinds of answers that you want because so much of it is controlled by the industry, and there aren't any reporting requirements. And so it's kind of hit or miss. And I do recall reading that they were doing an evaluation of what caused this. This doesn't mean that every Vestas V112 is going to collapse, but this is an example of what can happen. Vestas also has had, I think, 2 fires at the Kitty Mountain Maine project. These are Vestas V90s, so that's a 90-meter long blade, and 3 megawatts. And they put the cost of that fire for damaging that one turbine at about $4 million. Gamesa, the Locust Ridge project in Pennsylvania, which I visited 3 times, has had 2 fires. When it first went up, and then another one. These are Gamesa G87 2 megawatt turbines. In the most recently constructed Deerfield wind project, there are Gamesa G90s and G97 wind turbines. Gamesa has also had fires at an installation in Bear Creek, Pennsylvania, and that was a fairly recent one. And another one in Livingston County, Illinois, and literally, I could go on and on and on. There have been a lot of fires. I've heard that there have been lawsuits about the fires in Gamesa turbines. I don't know if they're specific to the G87s, but certainly these last 3 have been. And Sally will be talking more about fires. How often do problems happen, and at what distance? So an Imperial College of London study says that fires from wind turbines are probably occurring at about 10 times the rate that has been reported. There is a website, Caithness Wind, that's trying to document reports, and they report this lower number, but some researchers were able to estimate about 10 times that amount. Yes?
Can you give us any idea of how many turbines were operating where there were 117 or estimated to be 117 fires? In other words, is it 1% of the operating turbines or 10% of the operating turbines? Any statistics on that?
It's hard to know, and the Caithness wind data, which I did try and look at, is also a little challenging because a lot of it is based on smaller turbines of the size we don't have in Vermont, except for the ones at Searsburg. And so to try and, they don't give a lot of information about those kinds of things. And in trying to look at this issue, I decided to focus on what we know about, or what is known about what's what we have in Vermont, which is the 2.5 and 3 megawatt turbines, and it's not a lot. This is not a transparent industry in any way, and that's one of the problems, is that I can imagine there have been a lot of issues that have happened at some of these projects that we have no idea about because there are no reporting requirements.
So this 117 separate fires is all wind turbines that were operating when? Around 2014?
I think so. Now, there is a company that, or an insurance agent, GQ, and they publish annual reports, and so you have to request a report. So I've requested their most recent 2017 report. You could request a report, and you probably would get it. You have to say why you want it, and who knows if they'll give it to me or not. But every year they put out a report. I think their 2015 one was called Towering Inferno. Fire is a big issue for the insurers of these. And so I would be glad to pass that along to you, but I suggest that you try and get it yourselves. Ice storm is another one where it's very hard to get data on. However, this is a real thing that happened earlier this year with the Vestas 1.65 megawatt turbine, and it was at a community college in Massachusetts, and it threw the ice and broke a skylight, and it threw the ice about 626 feet based on looking at the nearest turbine on Google Earth. An Oklahoma Fire Department talked about ice chunks being recovered 125 yards from the base of the GE 1.6 megawatt wind turbine. Blade failures are actually the most frequent cause of problems with wind turbines. And so this is something that is acknowledged by the industry. And as turbines get older, all of these problems are, the chance of failure increases. This is what blade throw looks like. This is a Gamesa G90 of the type that is on one of the Ridgelines in, I think it's the one in Reedsboro, has G90s on it. And this is from January a year ago. This happened in France.
So if you could go back a little bit. So this piece of debris, how far, I assume it's coming from that turbine base we're seeing. How far is it from the turbine base to that piece of debris in the foreground?
I think I have a slide that doesn't specifically speak to that one because I don't know any more about it than this, but I do have something that has distance of blade throw a little further on. Right here. So this Vestas turbine blade shredded in high winds. It was from a V100, 1.8 megawatt, and the debris was thrown more than 1,000 feet from the turbine site in a working farm field. This is the summary of wind accidents from the Caithness Wind Farm Information Forum. Blade throw is the biggest number of incidents found due to blade failure. Pieces of blade are documented as traveling up to 1 mile. In Germany, blade pieces have gone through the roofs and walls of nearby buildings. And fire is the second most common incident. And this is where they had the data that they said was about 1/10 of what was actually reported, I think based on insurance reports. And they have that link to G-Cube Insurance there, so if you wanted to go and look at the G-Cube website and look at the information they have, that's where some of the data that is probably more reliable and more complete comes from. Structural failure is the third most common incident. And ice throw, this says that ice throw has been reported to 140 meters. Some Canadian turbine sites have warning signs posted asking people to stay at least 305 meters from turbines during icing conditions. So as we look at what Bryan's presented and what I'm finding, there does seem to be some sort of area in which these numbers converge.
And when we're using distance, is it what Bryan said, distance you're talking about is distance from the base?
From the base, right. So there are a lot of scientific papers, and especially on ice throw, I gather that in the Scandinavian countries, they have a conference every year called Winter Wind, and so there are probably lots of papers there in foreign languages. Language is a challenge when a lot of the good data comes from Europe, because there are not a lot of Ridgeline wind turbines in the United States. And so we are in a kind of a unique place that, we have to look at Maine, New Hampshire, and what we have in Vermont. So this is a paper by a couple of Danish professors, and for blade tip speeds of about 70 meters per second, the fragments thrown from the turbine can reach between 100 meters and 500 meters, depending on their size. Thereafter, throw distance picks up exponentially with tip speed. Now, it's my understanding that, and Preston from GMP can confirm this or not, that I think that the Lowell 3 megawatt V112s have a tip speed of maximum of 185 meters per second. So the higher the tip speed, the further that they can be thrown. And this is about blade throw. And then these same scientists or researchers have a paper on ice throw. Turbines operating at an extreme tip speed of 150 meters per second may be subject to blade throw of up to 2 kilometers from the turbine. For the ice throw cases, maximum distances of approximately 100 and 600 meters are obtained.
Just for reference, 70 meters per second is 156.5 miles per hour. Appreciate that extra.
Thank you. And some of these papers, I've only been able to find the abstract. You have to pay money to get the whole paper. I'll give you through the PUC whatever I'm able to get. This is another paper, a fairly recent one, Understanding and Acknowledging Ice Throw Hazard, Consequences for Regulatory Frameworks, Risk Perception and Risk Communication. Now, in the previous cases that we have seen in Vermont, the risk analysis is what's been used to figure out, there are not many people that go there, and so it's okay to have the shorter setbacks, and this paper, and I believe I do have the full paper on this, finds that recent theory of risk assessment questions the use of risk criteria for achieving optimum risk reduction and favors the use of as low as reasonably achievable principle. So they've actually studied ice that's collected at a Swedish wind farm. They've looked at the distances and the wind speed, and they are making a statement that the way that risk analysis has been used is not the best way to determine what the appropriate ice throw hazard area is. This is a paper from some American engineers, a method for defining wind turbine setback standards. And they have, on the right, comes from the state of New York, and it uses that standard shall be equal to no less than 1.5 times the sum of proposed structure height plus the rotor radius. I chose just one histogram. What they did was they modeled the blade throw examples for 3 different wind turbines. So this is for a 3 megawatt turbine. And going out on either side, these are what their models showed. And that's in meters. Their conclusion, this model, coupled with, and Bryan referenced, Monte Carlo simulation techniques, was used to simulate tens of thousands of blade throws for 3 example wind turbines of varying size. It was shown that typical current setback standards, which is this 1.5 times, do not provide adequate protection in those cases. And this is from the GD handbook, where these 1.5 times the total height if icing is likely, and for all turbines 1.1 times total height standard comes from. And I deleted the slide that Bryan said I was going to reference, but in Falmouth, Massachusetts, which if you want to sort of see ground zero for wind turbine noise issues, that's where there's huge amount of litigation going on. But Falmouth had applied for ARA funding, for American Resource Recovery Act funding, to put up a wind turbine, and they had to seek a waiver if they wanted to use a non-domestic model. And so in the Federal Register, there's reference to the GE refusing to supply American-made turbines because they didn't meet the setback due to the proximity to, I think it was the road. there were roads and structures and property lines. It may have been the property lines. I'll put that back in when I submit it. But so they didn't use American turbines because those were the only ones available, so they used some different model because the setbacks were inadequate. And
Yeah, GE refused to.
They refused to supply it, yeah. This is my final slide. There are other topics I didn't include. Oil spills. There was an oil spill up in the Sheffield Wind project when it first started up. These turbines can hold 100 gallons or more, and when they spill, who knows where it goes. Good luck regulating that one, but at least there should be some disclosure requirements about what's happening with these things. And if you're going to be spraying oil onto a neighbor's property, I think that's something that needs to be looked at. Bryan mentioned the setbacks to protect wind resources on neighboring properties, and the idea of having the disclosure requirements, I think, is something that would help advance this conversation a bit to find out how many lightning strikes have there been? Do you have lightning strikes from the fire? What are the accidents? Have they been shot? We've heard turbine blades have been shot. What exactly is going on up on these mountains, because these sites are very remote and it's rather hard to know what's going on because the industry controls all the information. So I thank you very much for allowing me to present that to you.
Thank you.
Again, I'm Sally Colopy from Fairfield, and I'm going to focus on wind turbines and fire mainly. So there's a fire in India that just, burned with the blades spinning out of control for several hours. So ABCO Fire Protection has been in business since 1975. They design, install, repair, and basically maintain a wide variety of fire suppression and life safety systems. So as the wind turbine fire cost soars, fire protection measures remain optional, and the consensus on the problem seems to be eluding the industry. And the concern is that, turbines are now 300 to 600 feet tall with, the blades, as we've said, over 100 feet, reaching speeds of 180 miles an hour. So they cited the Caithness Wind Farm Information Forum that stated around 20 onshore turbine fires per year. And again, this has kind of already been commented, but the British paper The Telegraph reported in 2014 that may be 10 times more actually fires, citing the data that Annette said from Imperial College and Renewable UK. And GCube, the insurer that Annette was referring to as a clean energy insurer, they estimate somewhere in the middle, around 50 incidents a year. And we have requested, Annette has requested their 2015 Towering Inferno report, so we'll see if we get that. But basically that's double what CWIF reports, and you can't help but question, because there's no requirements to report any of this stuff if this data is only the tip of the iceberg.
Ms. Colopy, on the previous slide,
Yeah.
the one even before this, where it talks about fire suppression, is there any statistical information about how many people are putting in the fire suppression?
I didn't run across that, no.
Thank you.
But, as mentioned, fire is the second leading cause of turbine failure, and due to the height of the turbines, the fire departments can only establish the safe zone around the perimeter, and try to keep it from spreading from nearby buildings, vehicles, while the multi-million-dollar turbine burns itself out. And this may be fine in wide open areas on a perfectly calm day with no wind, but you get stormy weather and windy conditions, and you're going to have burning debris scatter more widely, and obviously in dry weather conditions, you're going to have a wider area of fire risk. And that made me question, what about Vermont forest and turbines, several of the turbine installations that were proposed so close to housing. in Vermont. In 2014, the International Association for Fire Safety Science stated that 90% of turbine fires resulted in total loss and severe structural failure. And I apologize too, I ran out of ink on my printer, so I don't have the copies. But I do have a written report in Word that has all the links of everything that I mentioned, and I will submit that to the PUC with the backup documentation of my sources. But, you know, we all know that turbine costs can run around $4 million each, and G-Cube, that Energy and Shore, you know, feels that with the cleanup, when you factor in the cleanup and the downtime, it probably comes out to more like $4.5 million per incident. And they state that it's a growing problem that costs the industry $225 million a year. So being a Vermonter, you know, who was threatened, for lack of a better word, with a turbine installation, a poorly sited turbine installation. We're familiar with the term collateral damage. And, you know, collateral damage includes bystanders, nearby buildings and vehicles, turbine workers, and, of course, the adjacent wildfire-prone areas. It adds up to lost money, land, structures, and occasionally lives. And that all adds to the reputational damage that is fueling the anti-wind energy sentiment. For instance, in Australia, there was an 8,400-acre brush fire recently that destroyed livestock, outbuildings, and a home. And the environmental costs are staggering. Massive amounts of pollution and greenhouse gases are generated. A 2016 article in the engineering industry journal Structure says building sustainability features may be negated due to the additional carbon emitted into the environment through combustion of building contents. So I guess my question was, is it reasonable to argue if a fire completely negates any environmental benefit? Is it still green energy? And they go on to continue to state that the fire loading mainly comes from the fiberglass reinforced plastic on the turbine nacelle, which is the large, you know, gear house that we saw on fire, and the foam insulation. And they can store up to 235 gallons of oil and other flammable liquids inside. And there's thousands of feet of polymer-coated cable that run from the nacelle down to the transformer. And they state that the four main causes are lightning, electrical malfunction, hot surface, ignition, and maintenance. So what can be done about this despite inaccessibility and fuel abundance, ignition sources, high-profile, high-cost losses? There are currently, as we've said, no legal requirements to provide fire detection or suppression measures on turbines. And some U.S. states, the local authority having jurisdiction may provide fire protection guidance or require adoption of local codes, but that is typically only on turbines if the owner or insurer requires it. So there are some recommended best practices, though, and FireTrace, a fire system manufacturer, created a small self-contained system to protect the most fire-prone components of turbines. The National Fire Protection Association in 2010 released a recommended practice for fire protection for electric generating plants. And as a result of that, that started a process about codifying fire protection best practices for wind turbines by adding Chapter 10, which was identification and protection of hazards for wind turbine generating facilities. And in March 2014, the New Hampshire State Fire Marshal recommended that Iberdrola's Groton Wind cease operation until fire safety concerns were addressed. And the Fire Marshal actually told the state's Site Evaluation Committee, which was threatening to remove the plant's license and shut it down, that the independent fire suppression system was required by their state codes, which they did install, were required to install by that June date in 2014. So Wind Action reports in October of 2016 that despite a worrying rise in wind turbine fires, there's been little research into the matter and there are no agreed industry guidelines. In October 2013, a fire broke out inside of Vesta in the Netherlands as 4 contractors carried out routine maintenance. 2 escaped, but 2, a 19 and 21-year-old, found themselves trapped on top of the nacelle, and one jumped to his death, and the other was obviously found dead on top. And, you know, I debated putting that picture in, but those are the 2 individuals, and when you can zoom in close, they're hugging each other. And I can't imagine what they felt at that moment. When a fire suppression system could be installed, that might have saved their lives. So, other reports of damaging fires, and I won't read these word for word, but 220 acres of brush in California, 93. In Wales in 93, a 1-ton blade was thrown almost 500 meters. 97 in Wales, burning debris thrown 150 meters, setting the hillside and public right-of-way on fire. Another incident in Germany. All these are from Germany from 2000 to 2003, and they are a variety of, you know, mainly the blades rotating uncontrollably out of, you know, high speed for hours, and you can't control it. Blade parts traveling several hundred meters, not extinguished by driving sleet. This one, 3 mechanics had to undergo hospital treatment for fume inhalation. Another one traveling several hundred meters.
Since they've had these experiences, do many other countries like Germany require the fire suppression mechanisms?
I'd have to dig a little deeper into finding that out, you know, and see what they have for their, probably if they have best practice manuals or
if it's optional.
statute guidelines themselves that they've developed or added on to. This is kind of wordy, but this is December 16 in Michigan at Stony Corner Wind Farm. And basically it's this woman, Diane Ziegler, wrote into the local newspaper. She lives within 2 miles of 10 turbines, and one caught on fire. And basically she's just saying, you know, how much she deeply regrets signing that contract back in 2008. And no one informed me of the dangers of living so close to the spinning towers. And I can tell you firsthand that wind turbines are not safe for humans, animals, birds of all sorts, the environment, or your electric bill. They're not green, not clean, and not cheap. And then that Australia one that I talked about a few slides ago, that was in January with 8,400 acres. So now in May of 27, neighbors have submitted a $20 million class action lawsuit for loss of damage, and also to date in around that surrounding area has been 4 other serious brush fires have occurred. So this one in September of 2017 in Wyoming was known as the Cowboy Fire. Total acreage burn was 1,600 acres. The fire warden said, we had another one burn up in the past, but it was in the middle of the winter, so no problem. Here you got September 2017, an explosion of fire, 2 technicians hurt, another seriously injured 2 men. March of 2018 in Weatherford, Oklahoma, caught fire, burning 5 acres before being contained. And then just recently in Maine, at the University of Maine, a 65-meter turbine caught on fire. And that turbine is located, you know, less than 300 feet from the school soccer field and 1,000 feet from student dorms. So this is just a really short video that is going to show you a few fire incidences and other ones of turbine failure. This one's pretty powerful right here, this image. And I do not have the details of how far the debris flew, unfortunately. But it's quite the visual, knowing that that can happen. And have it be, you know, 2,000 feet from a neighbor's, a person's home, a homeowner. You know, unfortunately, these conditions, they're you know, probably low grass scrub land, which fires can spread really quickly, but they also can be contained a little bit because there aren't a lot of structures around. This is pretty powerful, and I saw a lot of videos like this of these shooting balls of fire. And we took off the audio on here because it was really loud, but you can hear the intense wind blowing on this. And then whoever caught this on video, and you know, we've heard about the kind of the aerodynamics that the turbines create, how it sucks in the birds and the bats. But those were grouped together. I did not create that video, so I realized that they're not all fire related. These are actual fires from the Oklahoma fire on March 28th, the one that I just talked about, that burned 5 acres before being contained. So all these past reports that I just mentioned, all these listings came from this Caithness wind report, wind farm information forum that Annette mentioned. And, you know, it has a really large list of accident and incident compilation that was started on November of 1980 and last updated, they say, March 31st. It includes 2,231 incidents, and many are fatal. Many of the fire ones, I only scrolled down to like 450 actually to create this report. Say no details to report, but others say debris scattered over large areas, and residents told to stay indoors and close windows due to poisonous fumes. So, you know, a wind turbine fire protection byline was developed by the Confederation of Fire Protection Associations in Europe, and I do have the link, and all these links and others are included in the written report. So questions that I thought of for the industry, for developers, regulators, and that local community should ask is, why are there so few regulations regarding safe placement of wind turbines, including fire protection equipment available at every turbine location? What is the net loss from turbine fires to homes, livestock, land use, wildlife, air quality? What are the health implications of turbines on fire? Where is the reporting and recording of ill health, displacement, and effects due to the burning chemicals, fumes, or pollutants? And what are the fire consequences of massive turbines that are proposed to be placed in locations like Swanton Wind was, with so many homes within 1 mile? And I guess some questions that I would, you know, ask you folks, not knowing exactly what the next steps are, is after hearing and having a chance to review this information, you know, what will you recommend? You know, a change in the setbacks, or how many feet, fire suppression systems, such, you know, that were required to be installed at Groton Wind in New Hampshire, reporting requirements for all incidents, because as was mentioned, they're not required. These incidents are not required to be reporting, and everything kind of, I'm probably not finding the right word, but, well, it's all proprietary. They can keep all this information, and they don't have to share anything. So it is difficult to find the reports, and I'll be really curious if we receive that insurance report from GQ. That would probably be quite enlightening. And any other questions? But I thank you for your time and for hosting this workshop and for caring. And I'm happy to try to answer any questions I can.
Do you have a recommendation on your previous slide when you're asking us setback? Do you have a recommendation on the setback?
Well, you know, I mean, when we were going through everything, we felt we wanted it 10 times the turbine height was the best thing. And ideally, from my personal standpoint, it would be 10 times at the property line, not at the homeowner's house, you know. So in other words, if this is my property line, this is my house, and he's the turbine or whatever, I want it from 10 times here, not 10 times here. But, and you know, that's the recommendation that, you know, many folks in our group recommended, and I don't think that's changed now. If anything, it's doing this. I mean, I've learned a lot more about turbines than I ever thought I would 3 years ago. And I'll tell you, it's been an eye-opener and a scary one. And and really spending, I probably spent 15, 20 hours just researching this presentation and learning about fire and trying to find information and watching a lot of videos, and it kind of confirmed that those setbacks are needed. And you really have to think about it because, and I did try to get in touch with some of the local fire departments, but I know that some people in our group from Swanton Wind had talked to some of the local fire departments in Swanton and stuff, and they basically said, there's nothing you can do. If you've got a 500-foot turbine, and if those blades are spinning uncontrolled, out of control, probably faster than 180 miles, and you saw that destruction of the blow apart, and how they were proposed at Swanton Wind like that, with all that, hundreds of acres of grass around, but also homeowners within, that 2,500 feet. I mean, that could be massive amounts of loss and destruction that could result from that one little maintenance glitch that went wrong in that turbine. So, I think VOSHA, I spent a lot of years in state and federal government, and VOSHA came to fruition as a result of the need and accidents, and I think a lot of things only do get implemented when there is a tragedy that happens. I think that's how it has historically happened. And I think we're learning so much more now about turbines that we don't have to wait for some tragedy to happen. They've already happened. And let's err on the side of caution when we move forward approving projects.
I have a question. Mr. Doobie had mentioned something kind of in passing earlier, 500 feet FAA regulation. Did I hear you correctly? And if so, could you explain that?
Yeah, so the FAA has a regulation that a pilot cannot fly lower than 500 feet. So as a consequence of that regulation, the wind industry the regulators have adopted that turbines will not go higher than 500 feet. In the Lake Ontario, they're proposing 600-foot turbines. I'm not sure how they're doing that, because that is a break from past precedent. The offshore turbines are going over 500 feet. So they're talking about 600-foot turbines, but the turbine manufacturers have limited themselves to 499 feet based on the FAA. But they're trying to get bigger for a lot of reasons. Efficiency. I did research your question before. So E is the charts on that previous. We looked at 300 meters. Yeah, so the E on that chart, thanks. The E on that chart is, these are strikes that are greater than 40 joules. There's a previous slide that explains why they picked 40 joules. Joules is a representation of energy. So for a strike, that's based on velocity, and I think it's 1/2 mv squared.
Yes.
Yeah, so kinetic energy is 1/2 mv squared. So 40 joules. So that's saying that the size of the fragment and the combination of the velocity at which it's traveling, the reason they pick E greater than 40 joules is the insurance company says if you get hit with a piece of ice with a fragment at 40 joules, that's a combination of mass and velocity, that's a fatal strike. So that's why they apply that. They're not talking about inconvenient strikes. They're talking about strikes that will kill a person. That's where 40 joules comes from, and that's why it's on the chart. And that's why it's by an insurance company is looking at it and saying, this isn't nuisance, this isn't flaking, these are strikes that could kill a person, 40 joules. And the meters squared is some depiction of 1 meter by 1 meter. I think it's a 1 meter by 1 meter target to represent a human person, and it's a head strike.
Is there anybody else who has any comments they would like to make? Yes, sir. Identify yourself if you would.
Greg Pierce, I'd like to amplify on the wonderful stuff that's been presented by Bryan and Nat and this sweet lady right here. The thing that troubles me is what I have watched in the regulation process is a trend towards satisfying the developer and not looking to the whole group of people who the developer's efforts are going to impact. You're going to at some point have to think about a factor of safety on the information that's been presented here by these three folks. 2 points. Bryan just lightly touched on the effect of the wind that's happening when the failure event occurs. So a blade detaches from the hub, and it does so because of the stress that it's under at that time. And then suddenly it's engulfed in a stream of air. Now, I'm a licensed pilot, and he's a very good licensed pilot. He flies the big ones. I just flew little tiny ones. But I know that when you get in an airstream, the stream of the air plus your velocity within the stream of air are additive. And you have all probably been passengers on an airliner. And you've heard the pilot call back and say, we had a tailwind. We're going to get into our landing site much earlier because of the tailwind. That's because those two velocities are additive. So I didn't see an awful lot in the technical information that was presented about how this, I'm going to call it an airfoil. The blade is an airfoil, so it is easily handled and moved by the wind. What the impact of the worst case scenario of the additive velocities. The velocity at the point of separation from the hub, and then add to that the velocity of the airstream that's moving away from the hub. And this could make, for distances perhaps a lot larger than what we've talked about here today. So I encourage you, when thinking about a factor of safety, keep that in mind, that there's a lot that isn't currently known and needs to be explored further. Thank you.
Anybody else?
Justin Lindholm from VCE. I have been around a lot of wind turbines in Vermont, and yesterday I was down at the Searsburg site owned by Green Mountain Power, and I saw something that I had not seen before, and it's normally a dangerous situation. The second turbine from the south was freewheeling at high speed. Generally, freewheeling of any sort of turbine or propeller blade increases heat in the bearings and causes it to blow apart. One of those pictures that Sally showed was a freewheeling turbine where it all of a sudden blew apart. And I don't know why, but Green Mountain Power is supposed to have sensors on these turbines. Now, these are the smaller turbines, not the bigger ones that are nearby. But they cause the turbines to blow apart if they can't control them. Generally, they will feather the blades. I've seen the blades feathered when they're not operating properly. This one was not feathered and it was still catching the wind. And the other ones beside it were going less than probably half speed that this one was going. And they did have a properly feathered one also that hadn't been working, and they had that thing feathered so that it wasn't picking up wind. But there's an example right there of something most likely went wrong. And if it had higher velocity wind, I wouldn't be surprised that thing was blown apart yesterday. So this stuff is not that uncommon. And I was over in New York State a few years ago where we watched a big turbine blade, one of the larger ones, over 400-foot turbine, was being brought into a big turbine site. And it was a replacement blade, so we got to talk to the fellow in command there while they were setting up to get the blade in. They had a huge convoy of trucks, and this thing was brought in on 2 separate trucks. Well, one truck way in the back with a blade so they can get around corners. And we asked him, what's that blade doing here? These are, all these have blades. He said, well, these blades give out a lot. And he said, this is my job. I go around the nation. Whenever there's a blade failure, I go in and I replace them with new blades. We did it all over the United States, he told us. And so blade failure, he said, it's a very common thing.
Mr. Lindholm, when you notified GMP that you saw this happening with their turbine, were you there long enough to see what their response was?
No, I wasn't there that long.
And did you call GMP?
No, I haven't. I mean, they had one blow apart right next to it, but they don't pay any attention to me.
Anybody else? Yes, ma'am.
Patty Rainville, Swanton. Being an old grandmother and having seen a lot of life, I would really plead with you to hear what you're seeing, to hear what they're saying, and recognize what you're seeing, and make your decisions with an extra layer of safety, err on the side of safety, as opposed to keeping everybody happy in the wind industry. That's all I have.
Anybody else? Well, thank you all very much. This has been extremely educational. We look forward to getting the materials that we don't have today that are going to go into the docket. And as you know, and that, you know, particularly, the EPUC takes comments all the time. So feel free to share with us any other thoughts. As I said at the beginning, we had no plan other than to listen and learn, and we've learned a great deal today. We're very helpful. Ms. Hayden, you had your hand almost up. Yes? No?
Do we file everything as public comment?
Yes.
Okay.
Yeah.
One thing that I'll be looking for, perhaps we'll get in some of the information that I suspect, is that these problems increase as the turbines age. So the Sheffield ones went up at the end of 2011, so they now have 12, 13, 14, 15, 16, 6 years operation. The Lowell ones have 5 years of operation. One thing that would be interesting to try and figure out is how much these issues increase. Like the ones that we're seeing with Searsburg, that fire, these turbines are nearly 20 years old now. And maybe the freewheeling that we saw, again, maybe there's more inclination. But in terms of the distances, it's like if they collapse, that's one distance. If they throw ice, that's another distance. If they throw blades, that's yet another distance. And so then the noise goes even further. Again, the fireball. So there are all these different categories of how to assess distance.
And you've done a lot of research. Have you seen things where they've tracked not the distances and back out of age? In terms
I have not seen the age piece. That's the one that I'm going to look for. Maybe if those insurance folks, I mean, like I said, you probably could get those papers better than depends. Some industry people will say anything and some won't. But
I do remember reading in some of my research that there is an assumption that they're going to break down more the older they get, just like cars do and humans do and everything. But they said that that's not necessarily true, and that they've had several new turbines that were put in and just failed due to either improper installation. A lot of it was attributed to incorrect maintenance, regular routine maintenance, and or just whatever, poor quality, just like you get a lemon car sometimes, you know. So I did read that on the few variety of insurance places.
Well, I did have a question that raises to me. Maybe Bryan might know the answer to this. As you know, airplanes have all kinds of certifications that they go through before you can fly an airplane, even small planes are included. Do you know, are there any national standards in this country or internationally for what criteria a wind turbine must meet in order to be able to be sold commercially?
You know, I'm struck by in answering your question, I'm struck by Sally's presentation from a cost-benefit analysis. If I put a $4 million turbine on a Ridgeline, I think I'd have a fire suppression system, and I think if I was the insurance company, I would require fire suppression just to protect the asset. It is also interesting, since you brought up the FAA, it seems like this industry is kind of evolving as opposed to mature, and there haven't been accidents where people, well, that accident that Sally showed was heart-wrenching. But if there was more awareness of that type of an accident, when you have a plane crash, there's a federal response. And then the PUC, as we've talked about in the past, you can't take off from Denver International. There's sound monitors the whole way. If I don't follow the ground track or have a lazy pull-off, we get fined. So we don't have the sophistication from the regulatory standpoint for a state to enforce fire code, noise standards. It seems like this is a global industry, and now we have a small state trying to deal with things like safety standards, fire suppression systems, constant noise monitoring, and I think the government will respond, but it seems like it's really being regulated by the states. So there seems to be almost a gap, and insurance companies will drive. I think, though, I know that insurance companies have standards. When you start to put a project on a ridgeline, they're much more conservative in a mountainous terrain than they are in. I know this from talking to Dave Learsworth. When you put a turbine in Kansas, it's a whole different. The margin of safety is much different than if you put it on a ridgeline with mountainous terrain. And that's just another example of, this margin of safety is really site specific. On a ridgeline is different than a laminar flow on a prairie where you have maybe 15 knots steady as opposed to mountainous turbulence. You have to have a smaller standard, a smaller turbine, because it can't take that. So that's a long answer to saying I don't know if there is oversight, but there certainly will be, from a going forward. But it doesn't appear to be, from listening to Sally, there's a good standard for fire suppression and inerting and those type of things.
So it sounds like it is a growing concern because, that 225 million that's just reported in industry claims, there's probably enough to getting developers to say, maybe we should be thinking about this.
I'm not aware of certification standards, but a few years ago, a group of us regionally got together with the head of the Low Impact Hydro Institute, because they have a certification process for dams. And if you do certain things, then you get a better standard. And we were looking at that as a possible model to try and develop our own standards that would provide some incentives for wind developers to do certain things. We didn't get very far with the concept, but it was an attempt to look at what could we put in place that would sort of rein the industry in. Is when you go to meetings, the wind developers in communities pitching these projects, they would pretty much across the board say, oh, these things hardly ever happen. Don't worry about it, it's not an issue. And so trying to develop a set of standards that admits that there are some issues, and that if you will acknowledge those and do these things to address them, then we'll support you more, something like that. But I'm not aware of any industry standard for the manufacturers. And for instance, some of the manufacturers that used to publish some of their data, their specifications in their brochures, don't even do that anymore for certain of the specs of the turbine. So it's contracting, it's not getting more transparent.
All right, well, thank you all very much.
Thank you.
Thank you.
Thank you.